Geometric design of highways deals with side distance, horizontal and vertical alignments, intersection elements, and cross-sectional components. Now we are here to learn some important concepts by answering some 10 questions that are most likely to be asked in various examinations. Now let's get into it. The first question is, the intermediate stopping side distance for a design speed of 65 km per hour, assuming f, that is coefficient of longitudinal friction, is 0.36 and the reaction time, that is small t, is 2.5 seconds. So we have to calculate ISD, intermediate stopping side distance. Your options are option A 91 meter, option B 273 meter, option C 212 meter, option D 182 meter. So what is the correct answer for intermediate stopping side distance? There are many SDs like stopping side distance, ISD, HSD and OSD. Now we are here to calculate ISD only. You can pause this video and calculate the answer and check it. So the correct answer is option D 182 meter. Now let's see how it is calculated. So first we have to consider the velocity or the speed of vehicle as 65 km per hour, and we are converting that into meter per second so that there will be no clash in units. Stopping side distance SSD is given by this formula: Vt plus V square by 2g into F plus or minus n. What is n? N is nothing but the gradient value in percentage. Here they have not mentioned anything about gradient, so this one is left out. This one is cancelled out. So v square by 2g f only. So f is 0.36, g is 9.81, v is 18.056. So substituting all those things in this formula, we will get the answer as 91 meter for SSD value. We are supposed to calculate only intermediate stopping side distance. So ISD is given by 2 times SSD. So 2 into 91 gives 182 as answer. So option D is correct. Now let's see something more about ISD and SSD. So on an horizontal curve, so why ISD is provided? On an horizontal curve, the requirement of OSD cannot be always satisfied. So that's why we are providing ISD. That is nothing but twice the stopping side distance SSD. And when it comes to ISD, height of eye level and height of object both are considered as 1.2 meter above the ground surface or the above the road surface. And when it comes to two-way traffic in a single lane road, SSD shall be twice that of the required obtained SSD value. So these are some important points regarding SSD and ISD. So ISD is nothing but twice that of SSD. SSD is given by this formula, Vt plus V square by 2gf. When gradient value is mentioned, we have to substitute like this, f plus or minus n in percentage. Now let's move on to second question. Second question is based on a super elevation, or we can say some centrifugal action in a curve with all the relevant conditions remaining the same. The speed of a vehicle negotiating a curve is proportional to option A weight of vehicle, option B 1 by root of weight of vehicle, option C root of the weight of vehicle, option D reciprocal of weight of vehicle. So what is the correct option with respect to the speed of vehicle with all the conditions remaining the same? What are the other conditions? Centrifugal force and radius of curve. What else? Velocity. So these conditions remaining same. What is the speed and weight relationship? So nothing but option B, reciprocal of root of weight of vehicle. Now let's see how it is obtained. This is how we are obtaining the relation between weight and velocity relation. So P by W is equal to V square by GR. This is nothing but impact factor, or we can say centrifugal ratio in by other name. and P is nothing but centrifugal force. So you can see in this diagram, this is the centrifugal force and opposing force is the centripetal force. So centrifugal force divided by weight of vehicle is equals to V square by Gr. So this P by W ratio is nothing but we can call that as impact factor or centrifugal ratio. So typical values for roads and railways is given us like this: 1 by 4 for roads and 1 by 8 for railways. So if you substitute 1 by 4 here and calculate the velocity values by considering some radius of curve and GS 9.81, you will get one value, and that value related to railways, we get the answer as V for road, that is maximum speed in case of road will be equal to root 2 times that of railways. So this is an observation. This is an observation when we substitute the value of P by W value, that is impact factor. And let's say something more about it. When P by W is less than B by 2H, then to avoid actually overturning, the relation should be like this: P by W shall be less than or equal to B by 2H. So what is B? B is the width of vehicle, H is the height above the ground. So P by W shall be less than or equal to B by 2H. Then only we can avoid overturning. And the P by W ratio shall be less than or equal to F. Then only we can avoid transverse skidding or lateral skidding. If B by 2H is less than F, less than or equal to F, then high amount of friction is there. What does it mean? Overturning will occur before skidding occurring. So overturning before skidding, B by 2H less than or equal to F. So these are about some relations between impact factor and the corresponding B by 2H value to avoid overturning, skidding, and like this. And another important formula for impact factor is this one: 1.59 into NV square by L. So n is nothing but deviation angle, that is algebraic difference between the gradients, and V, here V is written in capital letters. Whenever V is written in capital letter, then the unit would be kilometer per hour. When V is in small letter, then that unit will be meter per second. So this is how we have to follow the sign conventions. So here 1.59 into NV square by L is the impact factor in percentage. This is one important formula that is used in various problems. So these are all about the impact factor. P by W is equal to V square by ZR. Now let's move on to third question. Third question is based on transition curve. The standard equation of cubic spiral transition curve. There are many types of curve. Here you can refer in this diagram: spiral, cubic parabola, Bernoulli-Lemniscate, like this, sine curve. There are many types of transition curves available. Now we have to find the option for cubic spiral transition curve. Standard equation for cubic spiral transition curve. So among the four options, what is the correct equation for cubic spiral transition curve? So the correct equation for cubic spiral transition curve is option A, y is equal to L cube by 6RL. Now let's see more about the other curves. Actually, for transition curve, ideal curve is clothoid, or we can say spiral. That for that equation, for the spiral, the equation goes like this: phi is equal to L square by 2 pi RL. Phi is nothing but the angle. This angle they are denoting. Phi is equal to L square by 2 pi RL. Why ideal transition curve is clothoid? Because this C remains constant. What is C? Acceleration, radial acceleration. So radial acceleration C value, meter per second square per second, rate of change of radial acceleration, that remains constant in case of clothoid transition curve. So that's why this clothoid or spiral curve is identified as ideal transition curve. And the spiral angle is given by this formula: L by 2R. And for valley curve, and let's see some other curves with respect to the function. For valley curve we use cubic parabola. Cubic parabola is the best suited for a valley curve, and that equation is given by y is equal to x cube by 6rl. So y is equal to x cube by 6rl is the uh, valley curve equation, cubic parabolic valley curve equation. So x cube 6rl, here L cube 6rl. So there is some difference. This is x axis value. This is the x, but here L is nothing but length. So cubic spiral transition curve is L cube by 6rl. When it comes to cubic parabolic valley curve, it is x cube by 6rl. Now let's say some other point. For up to 12 degree, cubic spiral and cubic parabola are one and same. So this formula and this formula are same up to 12 degree. After in higher degree it will vary. So that's why there is some difference between these two formulas, clothoid and cubic parabola. Clothoid is ideally suited for transition curve. Cubic parabola is ideally suited for valley curve. So all the three curves, spiral, lemniscate and cubic parabola, you can see in this diagram. Lemniscate, spiral, cubic parabola are one and same up to 4 degrees. So up to 4 degree deviation, these three curves behaves one and same. Beyond that only, these three curves has unique significance. And for summit curve, the curve adopted is square parabola. Square parabola is for summit curve. Cubic parabola is for valley curve. So this is the summit curve and this is the valley curve. Ideal summit curve is circle, but best suited is square parabola. Why ideal summit curve is circle? Why ideal summit curve is circle? Because side distance available throughout the curve is constant. So that's why circle is the ideal shape for summit curve. But due to good riding qualities and simplicity of calculation, the best curve for summit curve is square parabola. Ideal is circle, best suited is square parabola. There is difference between best and ideal. When it comes to ideal curve, it depends on side distance criteria. So that's why circle is the ideal summit curve. But in case of comfort, best ride quality and simplicity in calculation, square parabola is the best one. So there is one difference. And what is the length of transition curve? How that will be calculated? By using this formula. LS is nothing but maximum of V cube by CR. Here V is in small letter. That means V velocity value has to be substituted in meter per second. Here by CR. C is nothing but rate of radial acceleration. That will be given by using this formula, 80 by 75 plus V. Here V is in capital letter. That means kilometer per hour. So another one is EB into N by 2. So what is E? Super elevation. B is nothing but width of highway, including the extended width or widening. So there is one concept of widening of curves. So that is included in this capital B. Into N. N is nothing but rate of super elevation. This will be respect corresponding to the uh, curves, that is that curve is in a high flat road, or that curve is in built road, or that curve is in highway or hill roads. So that depends on, if it is in mountainous road, then n will be 60. If it is in plain, if the highway is constructed in plain areas, then n will be 150. So for mountain it is 60, for plain it is 150, and for built up areas it will be 100. So these are some typical n values, that is nothing but rate of introduction of super elevation. So it is n will be 60 for mountain, 150 for plain areas, 100 for built up areas. And this by 2, EBN divided by 2, that will be come when the curve is then the pavement is rotated about center. When the pavement is rotated about inner edge, then this by 2 will not come, only EBN. And another criteria is 2.7 v square by r. Here v is in capital letter, that means velocity should be substituted in kilometer per hour. And 2.7 v square by r is based on IRC codal provisions. And 2.7 v square by r is for plane. And when it comes to mountains, it is only v square by r. So this is how we have to calculate length of transition curve. There's nothing but maximum of v cube by cr, EBN by 2, 2.7 v square by r. And c is found by using this formula 80 by 75 plus v. Now let's move on to fourth question. This is based on a valley curve. We have to find the lowest point. A descending gradient of 4% meets an ascending gradient of 1 in 40, where a valley curve of length 200 meter is formed. So length of valley curve they have given. What will be the distance of the lowest point on the valley curve from its first tangent point? So this is the first tangent point. So we have to calculate the distance between that lowest point and first tangent point. So how to calculate that? Option A 100 meter, option B 111 meter, option C 125 meter, option D 118 meter. So we have to calculate the distance of lowest point on the valley curve from its FTP, first tangent point. This is one simple formula we have to remember so that we can find the answer for this question. So option is option B 111 meter. Now let's see how it is calculated. X is equal to capital L, that is the length of the curve 200 meter, into n1 divided by 2n. n1 is the descending curve, descending gradient, sorry, not curve, descending gradient. So L is nothing but 200 into n1 is 4% divided by 2 into capital N. What is capital N? Algebraic difference between two grads. So algebraic difference, so n1 minus n2. So n1 is plus 4, sorry, n1 is minus 4 because descending gradient, minus 4, and minus n2 is an ascending gradient, so plus what, 1 in 40, so 1 by 40, that's it. So the answer is the capital N value. So substituting all those things in this formula, we get 111 meter as the answer. That is nothing but distance of the lowest point on the valley curve from its first tangent point. X is given by x is equal to L into n1 by 2 capital N for 1 by 2, or we can say root of n1 by 2n. Now let's see more about a valley curve. How length of valley curve is measured based on comfort condition, headlight side distance, SSG and OSG. From based on comfort condition, this is the formula. L is equal to 2 times LS. LS is transition curve length, length of transition curve, and 2 into NV cube by C. N is algebraic difference of angle or deviation grade. NV cube divided by C. C is the what, meter cube per second cube. That is nothing but rate of radial acceleration. So NV cube by C whole power 1 by 2, or root of NV cube by C. So this is how we have to calculate length of valley curve based on comfort condition. And based on HSD, L is equal to ns square by 1.5 plus 0.035. 1.5 plus 0.035 S. S is nothing but side distance. Only when length of valley curve is greater than side distance. If length of valley curve is less than side distance, then formula will get changed like this: 2s minus the reciprocal of this. How to calculate that? L is equal to 2s minus reciprocal. So 1.5 plus that 0.035 value divided by n. So this is how we have to calculate when L is less than SD. So when L is greater than SD, we have to adopt this formula. L is equal to n square by 1.5 plus 0.035 s. In the same way, for SSD, L is equal to n square by 4.4 when L is greater than SSD. When L is less than SSD, it is 2s minus 4.4 by n. And for OSD, L is equal to n square by 9.6. When L is less than OSD, it is 2s minus 9.6 by n. How to calculate the radius of valley curve? Given by this formula. Radius of valley curve is capital L, that is the length of valley curve, divided by 2n. So these are some important points about valley curve calculation. Now let's see fifth question. A parabolic vertical curve is to be set out connecting uniform grades. 0.6% and 1.0% both are ascending gradients. The rate of change of grade is 0.06% per 30 meter. We have to find the length of the curve. This is one easy logical problem you have to calculate. So they have given the rate of change of gradient as 0.06% per 30 meter and two uniform grades, both are ascending. By using this data, we have to find the length of the curve. This can be solved by using logic. Easy one. Option C, 200 meter is the answer. So change of grade is nothing but 1 minus 0.6, capital N, or we can say deviation. Yeah, N is 1 minus 0.6, so 0.4 percentage, and rate of change of grade is 0.06 percentage per 30 meter. For 0.4 percentage, what is the length? So 0.4 divided by 0.06 into 30 gives the answer as 200 meter. So this is a simple problem. Now let's see more about grade compensation. So grade compensation is not needed for gradients flatter than 4%. This is as per IRC code. And when radius of horizontal curve is greater than 45 meter, grade compensation shall be 30 plus r by r. And what is the compensated gradient? Ruling gradient minus this grade compensation value. And when horizontal radius is less than 45 meter, grade compensation shall be 75 plus 75 by r. So this is how we have to calculate the grade compensation. Now let's move on to sixth question. Sixth question is based on widening of roads. So widening of the roads and curves, in hilly region. So in hilly region, how it is done? Option A, on the outer side alone. Option B, on the inner side. Option C, equally on both the sides. Option D, less on outer side, more on inner side. So what is the correct side or correct construction of widening of the roads? Whether it will be widening on the outer side only or inner side only, or equally on both the sides, or less on outside and more on inner side. In hilly region, that's the main thing. So in hilly region, widening of roads is done on the inner side only, not on the outer side, or equally. On the inner side only, widening is done. Only in plain regions, both the sides are done. Now let's see more about it. Why widening is done? Because of this off-tracking phenomenon. So what is off-tracking? The rear wheels follow inner path on the curve. So you can see in this diagram, this is rear wheel. So that follow what? Inner path on the curve. So this is the inner path. So the rear wheel follows the inner path on the curve as compared to front wheels. This is the front wheel and this is the rear wheel. So you can see in this diagram clearly, rear wheel follow the inner path as compared to front wheel. Front wheel is correctly projected, but rear wheel is not. So that's why widening is given. Mechanical, there are two types of widening, mechanical and psychological. So mechanical widening is given by this formula. This is nothing but the off-tracking formula. NL square by 2R, N is nothing but number of lanes in the highway. So NL square by 2R. L is nothing but the length of wheelbase divided by 2R. R is radius of curve. Psychological widening is given by this formula, V by 9.5 root R. Here V has to be substituted in kilometer per hour. V by 9.5 root r. WPS is not considered for single lane road. So only in multi-lane roads, psychological widening is considered. In case for single lane road, psychological widening is not considered, only WM is enough. And based on the radius of horizontal curve, how widening is provided. When horizontal curve radius is less than 50 meter, then extra widening is provided at inner edge only. When it is greater than 300 meter, extra widening is not at all required. When it is between 550 and 300, then extra widening is provided equally at both the edges. So equally at both edges, extra widening is provided. Even in case of hilly region, widening is provided on inner side only. Now let's move on to seventh question. Full amount of super elevation on an horizontal curve is provided at the. So this question is purely based on super elevation. Option A, beginning of the transition curve. Option B, center of the circular curve. Option C, end of the transition curve. Option D, center of the transition curve. So full amount of super elevation is provided at which location? You can refer this diagram to get the correct answer. Whether it is beginning of transition curve or center of circular curve or end of transition curve or the center of transition. So the correct option is option C, end of transition curve. You can see in this diagram, super elevation is gradually provided like this and reach the maximum at here. So this point, super elevation is reached fully. So what is that point? Beginning of the circular curve. This is the actual circular curve. At the beginning of the circular curve, super elevation is attained at maximum. That means actually this is the circular curve and this is the transition curve. These are the transition curve. So circular curve, transition curve. This is transition, this is circular. So at the end of the transition, or we can say at the beginning of circular curve, super elevation is provided full amount. Now let's see more about super elevation and its calculation. E plus F is equal to V squared by GR is the basic formula for the super elevation, where F is the nothing but lateral friction coefficient. Here F is lateral friction, but in SSD calculation, that the coefficient of friction will be based for longitudinal, not lateral. So that's why there F value will be some 0.36, 0.35 like that. Here lateral friction. Here lateral friction. Lateral means like this, perpendicular to the direction, perpendicular to the movement. So lateral friction is F is equal to 0.15 typically. So E plus F is equal to V square by GR. So as per IRC, these three formulas are followed for a mixed traffic condition. E is equal to 0.75 V square V the whole square. This square is not for only velocity. This is a whole square. 0.75 V the whole square divided by GR. Whenever small v comes, this is for meter per second. Only capital V means kilometer per hour. And another formula for lateral friction is V square by GR minus 0.07, because E shall not be greater than 7%. And in case of snow roads, it can be maximum up to 10%. In case of normal roads, it shall not be greater than 7%. So that's why F is equal to V square by GR minus 0.07. And this is the allowable velocity formula. Allowable speed V suffix A is equal to root of 0.2 to 0. So these three formulas are based on IRC and it is meant for mixed traffic condition. And there is one concept called equilibrium super elevation. That means we are not considering the friction value. Only we consider there exists no friction. That is F is equal to 0. So that means that super elevation is equilibrium in condition. So equilibrium super elevation is given by this formula. E is equal to V square by GR without considering the lateral friction. And how super elevation is attained? There are two methods: by rotating about inner edge, by rotating about the center line. So this is the center line. By rotating about the center line, we can attain the super elevation. Here in this diagram, they have attained the super elevation about inner edge. So this is the inner edge. So super elevation obtained like this, rotating about inner edge. When in case of hill, rotating about inner edge is followed. In case of flat terrains, rotating about center line is followed. So there are two applications. Now let's move on to eighth question. Horizontal curve of radius r is equal to 260 meter on a two-lane road, two-lane two highway. Width of two-lane road is given as 7 meter. Design speed is given as 65 km per hour. And stopping side distance SSD is 130 meter. We have to calculate the setback distance from the center of inner line. So every point is important. Every word is important. So options are A 8.14, B 7.14, C 5.14 meter, D 9.89 meter. So what is the setback distance? You can refer this diagram to get what is the setback distance. Just pause the video and calculate by using correct formula and check the answer. So the correct option for setback distance based on this criteria is option A 8.14. Now let's see how it is calculated. So first we have to assume length of curve is greater than SSD. So by assuming that, we get this formula: m is equal to r minus of r minus n minus 1 d cos alpha by 2. So what is r? We know radius of curve. And what is n? Number of lanes. Here 2 lane road, so 2 minus 1 1. What is d? D is nothing but distance between center line of the road to the center of inner line. So let's see what is that. So consider this as the two-lane two-way road. So here what is the small d value? Between center line of the road. So this is the center line of the road. This is the center line of the road to the center of inner lane. So let's consider this as the center of inner lane. So this distance is nothing but small d. So this distance is small d. Now we have to calculate alpha by 2 value. So that will be calculated by using this formula. Alpha by 2 is equal to 180 s by 2 pi into r minus t. So what is s? Side distance. They have given 130 meter. So by using this formula, we get the answer for alpha by 2 as 14.42, and that value will be substituted here so that we get the value of setback distance. And this setback distance is a distance from center of the highway, center of the road. You can see in this diagram. Here what is mentioned? Center line of road. So from that, m value is got, n value is obtained as 9.89 meter. You may see in the options. Option D is given as 9.89 meter. But in the question they have asked for setback distance from the center of inner lane. So this is the inner lane. So we have to calculate setback distance from this value. We have to calculate setback distance from this one. This is the center of inner lane. So from this we have to calculate setback distance. So for that we have to minus the small d value. So that's why m minus d is calculated to get the answer for setback distance from center of inner lane. Center of inner lane to the line of sight. So how to calculate small d value? It is nothing but 7 by 4. What is 7? Width of the two lane road. So small d is 4 times small d gives the width of the line, width of the road. So small d value is 7 by 4. We can calculate like this. M minus d value gives answer as 8.14. So option is A. So what about other cases? If it is asked for center line of outer line, then m plus t. So this is the center of outer line. So here one small d will be there. So that's why m plus t. When it is asked for inner edge, this is the inner edge, this is the inner edge, then we have to add one when we have to subtract two d's, here one d and here one d, so that's why minus 2d. When it comes to outer edge, this is the outer edge, so we have to add this d as well as this d, so that's why plus 2d. So that's why plus 2d. So this is how we have to specify the answer based on the given criteria. So basically we are finding the value of setback distance from the center of highway. Center of highway. This is the center of highway or center of road. But in the question they have mentioned from center of inner line. So that's why m minus t. Now let's move on to ninth question. This question is based on OSD calculation, one important concept in highway engineering. OSD, overtaking side distance. They have given the design speed of the highway and the acceleration as 0.53 meter per second square. So these are four options to get the answer for safe OSD value. So there are some 2 to 3 calculations involved in this OSD concept. You can pause this video and get the answer and check it. So the correct option is option D, 750 meter. Now let's see how it is calculated. Basically OSD formula is the summation of these three distances. What are those? D1, D2 and D3. So D1 is given by VBT. What is VB? VB is nothing but velocity of overtaken vehicle. Velocity of overtaken vehicle. That is velocity of this vehicle. This vehicle is the overtaken vehicle, right? So this vehicle has the velocity VB. So velocity of overtaken vehicle into time, reaction time. Basically in calculation for OSD, we take reaction time as 2.0. But in case of SSD calculation, stopping side distance, we take reaction time as 2.5 seconds. Please note it, because in SSD we take 2.5 seconds as reaction time. In OSD we take reaction time as 2 seconds only. So that's why VBT is equal to 23.33 into 2. How 23.33? We are calculating in meter per second. How it is 84? Basically, overtaking vehicle minus 16 kilometer per hour gives the answer for velocity of overtaken vehicle. This is some general assumption, because when the difference between two vehicles is 16 kilometer per hour, then overtaking can be done. So that's why overtaken vehicles velocity is nothing but overtaking velocity minus 16. So that gives answer as 84, and that is converted into meter per second as 23.33. So 23.33 into 2 gives the answer for D1 distance. This is the D1 distance. And D2 distance is given by this formula. VB capital T plus 2S. And how capital T is calculated? By using this formula. Root of 4S by A. Root of 4S by A. And what is S? This is nothing but it is related to the spacing between vehicles, and that will be given by this formula: 0.7 velocity of overtaken vehicle, that is V suffix B, plus 6. 6 is nothing but length of wheelbase. Length of wheelbase is normally 6 meters. In some case it will be 6.1 meters. If it is mentioned in question, we have to adopt that only. But normally 6.0 is the length of wheelbase. So spacing is given by 0.7 VB plus 6, and it is small VB. That means VB should be in meter per second. So 0.7 into 23.33 plus 6 gives one answer. That answer has to be substituted. That value of spacing S has to be substituted over here. 4 into S divided by A. A is given as 0.53 meter per second square. Sometimes acceleration will be given in terms of kilometer per hour per second. So that has to be converted into meter per second square, and then that value is substituted over here. So 4s by a and root of that thing will give the answer in seconds for capital T time. So VBT plus this capital T is nothing but overtaking time. Overtaking time. So VBT plus 2s gives the answer for what? D2. Why 2 times yes? Because here one spacing, here one spacing. So that's why 2 times yes value. You can see here 2s plus VBT. VBT is this small b. So this is the D2 value, and D3 value is nothing but V into T. V into T. Here V is for velocity of overtaking vehicle in meter per second. So this is how we have to calculate every distance value. When it comes to a single lane or single way road, one way road, then D3 will not be there. Only D1 plus D2. When it comes to two way road, we adopt all the distance value, all the three distances. So when it comes to only one lane road, D3 will not be there. But in this question, they have not mentioned about the lanes or ways of road. So we are adopting all the distance values. By calculating, by summing up D1, D2, D3, we get the OSD value as 763.32, and that is approximated to 750 meter as per the given options. So that's why option B is correct. Now let's see the other important point in overtaking zone. So maximum length of overtaking zone shall be 5 times OSD value, and the minimum length of OT zone shall be 3 times OSD. So these are the concepts behind OSD, overtaking side distance. This is how we have to calculate OSD values. Now let's move on to last question, 10th one. This is based on Camber. So value of Camber recommended for cement concrete roads in heavy rainfall. In heavy rainfall, what is the Camber in case of cement concrete roads? Whether it is 1 in 50 or 1 in 40 or 1 in 33 or 1 in 25. So what is the basic value of Camber recommended as per IRC for cement concrete roads during heavy rainfall? In heavy rainfall case, what is the value? So the option is option A, 1 in 50. Now let's see some other values with respect to other criteria. So in case of cement concrete and a high type bituminous surface, it ranges from heavy rainfall to low rainfall, 1 in 50 to 1 in 60. In case of thin bituminous surface, it will be 1 in 40 to 1 in 50. And in case of waterbound macadam, and in case of gravel pavement, it will be 33 to 40, 1 in 33 to 1 in 40. And in case of earthen roads, it will be 25 to 33. So these are some typical values based on IRC code. And other important points regarding camber, camber shall be 0.5% is cheaper than cross slope of adjoining pavement. This is one criteria about camber. And camber shall be 3% is minimum. Why 3% is minimum? To drain the rainwater. Only function of camber is to drain the rainwater. So minimum 3% is to be provided, and maximum 5%. Why maximum value? Because if it is more than 5%, then toppling of vehicle may occur. So to avoid toppling of vehicles like lorries and truckloads, so camber shall be up to 5%, not more than that. So 3 to 5% we have to adopt for camber. Only only function is to drain the rainwater. And the gradient shall be 2 times the camber. Gradient shall be 2 times the camber. So these are some important points about camber. Now we are at the end of this video. If you like this video, please like, comment, share with your friends. Thank you. Thank you for watching.